recording.
Hi, this is our ME154 final project with Professor Armani. Our project is the soda dispenser design. My name is Eulix,
I'm Travis.
And I'm Lynn.
and we also have Patrick Fusilero. Next.
I got you.
So here is the picture for our project. So just a little bit of background. We believe that everyone wants a soda machine in their home. And now with our soda machine design, they can. So by using 4 2-liter soda bottles in our machine, it can pour the same amount of liquid into one single cup. You can make it into one simple drink just by separately pouring the 2 liters of the same soda, or you can even mix sodas so it can taste even better and you can find different flavors. So this simple mechanism we came up with can make this a household item in anybody's home to enjoy.
All right. The design process. We thought of many ways to make a functioning valve, and the best way to do that we found was with a lever, and we have a crank slider mechanism. To make sure the crank slider mechanism did not get in the way of our valve for opening the soda and letting it through, we had to make it short enough yet strong enough. The force of the cup pushed on our trigger for unleashing the valve is minimal, but also very important. And we found the best way possible to account for this was to keep the crank slider. We originally had a stationary bar, but found out that the crank slider works better. This is because it will reduce the stress and strain of the rest of the mechanism, especially the lever and valve, which is the least strong part of our mechanism. So our bill of materials, our stationary bar, which is the left and right, our trigger bar, which you push the cup against to unleash the valve, the coupler bar, which connects the sliding bar and the trigger bar together, the sliding bar, which slides back and forth when pushing the trigger bar onto the valve, the sliding tube, which holds the sliding bar at a certain point and won't let it go too far, the bottle holder, which will hold all 4 of the 2-liter bottles, the valve blocker, which blocks where the soda comes out and is pulled back with the trigger bar and the sliding bar, the funnel to catch the soda going into our cup, the bottle, which is obviously the 4 2-liters, and a pivot, which can pivot our entire mechanism. So this is our 3D design. As you can see, we have the four 2-liter bottles. Here we have the trigger bar, which is connected to the sliding bar and the coupler bar. And the slider bar will go into the sliding bar tube, which will hold it at a certain position and make it where it opens the valve, but does not go too far to break the mechanism. And then here at the bottom is the funnel and the pivot.
Okay, so force and stress analysis. So from our analysis and our calculations from our old reports and our old assignments, we found that the critical points on the individual components are expected to be at the connecting joints and center hole of each link. So based on the stress portion calculations, it's determined that the connecting joints would fail first before the center hole. Also, since the slide tube resulted in the lowest stress value, the critical component of the mechanism would be the tube itself, which is circled in the picture shown. For static failure, we calculated that the factor of safety of the mechanism's individual links to be around less than 0.1, which is pretty poor for a safety factor. We surmise that there's probably some calculation errors to obtain that result, but then ideally we would like the mechanism to have a higher safety factor.
Next slide.
Mm-hmm.
Okay, so for the prototype, instead of making the model out of the material that were listed in the bill of material, we decided to go for wood and plastic, which were easy to find at the store and affordable. So all of our crank that show in the right picture, the picture on the right side, they are made of plastic connected by bolts and nuts. Our platform that go on top of it were made from wood. We drilled 2 holes that fit the size of the Starbucks cups. Inside the Starbucks cups, we also drilled 2 holes so that the water can get released from there. And the picture on the left side is the front view of our prototype.
Okay.
Next slide.
And here is Patrick's part of showing how the mechanism works.
For our drink dispenser project, we decided to use a crank slider method for our mechanism. As we go back down to each link, we first have the trigger link as designated by the green ruler, our coupler link, which is designated by the red ruler, and our slider link, which is designated by the blue ruler. As we pull back the trigger, we can see that it pushes back onto the coupler link, which then in turn pulls back on the slider link. The slider link is connected to the stopper, which is holding back the liquid.
And then here's the top view.
Here we have the top part of our project where it's better to see the stopper going in and out of the mechanism. As you can see below, each cup has holes into the center of the cups. This is where the liquid will be dispensed. It is currently being stopped by the stopper, which is seen as the black part of the mechanism. As the trigger and stopper is pulled back, the liquid will be dispensed and be funneled into the cup of your choosing.
And then here is the mechanism working. I
Here we
don't
have
know
the
how to
top.
skip all these. All right, there you go.
So now let's move on to some of the difficulties of the fabrication that we have. So in this process of making this model for the project, our group ran into a couple of technical issues. For example, we had a pretty hard time to find a waterproof material for our stopper that goes underneath the platform to stop the water from running. Our material is quite flimsy as well. And we also didn't have enough of tool available to make our model as we expected. But despite all the difficulty that we have, all of our group members did really try to think creatively to solve the problem that we were facing while making the model. Through this project, we had a chance to practice many concepts that we learned in class. We also had the opportunity to learn how to use some of the machine tools that are available, and we also get some hands-on experience. So through this class, we learned some concepts that help us move forward in the future in our design career.
All right.